Good morning, students. So today's online class will be of special concrete. The topics are geopolymer concrete, high strength concrete, high performance concrete. Contains geopolymer concrete, high strength concrete and high performance concrete. Geopolymer concrete. Geopolymer concrete is an organic aluminosilicate polymer synthesized from predominantly silicon and alumina materials such as a fly ash. So fly ash is a product which is a byproduct of combustion of the particular coals, and we are able to have that particular fly ash. That fly ash is again reorganized, and if any other product is prepared, then we are able to have some polymers. These polymers are the which we are having synthesized them, then we are going to prepare a geopolymers. Alkaline solutions are used to introduce the silicon and aluminum atoms in the source materials fly ash to dissolve to form a gel. So alkaline solutions are used to induce in the solution of silicon and aluminum atoms such that they prepare the fly ash into the dissolved form of a gel. The polymerization process may be assisted by applied heat followed by drying. So polymerization means we are going to make it separation and getting into a form type of gel. So that is assisted by the up of a heat of flowed by the drying. The geopolymer gel binds the loose cores and fine aggregates to form a geopolymer concrete. So geopolymer is one type of a gel which binds the loose coarse aggregate fine aggregate to form one type of a geopolymer concrete. Geopolymer gel replace the calcium silicate hydrate gel in the cement concrete. Chemical reaction period is substantially fast and the required curing period may be within 24 to 48 hours. So we have that calcium silicate hydrate gel wherein we are just replacing that with the use of the particular geopolymer gel, wherein that part is also nowadays is used as a cement concrete. Chemical reaction period is substantially fast, means the reaction what the takes place instead of calcium silicate hydration in this geopolymer takes it in the faster rate. That is what we require the curing period only between 24 to 48 hours itself. Advantages of geopolymer concrete. Geopolymer possesses excellent mechanical properties. Excellent mechanical properties means we have compression strength good and tensile strength also some part of bit better than the normal concrete. Does not dissolve in acid solutions. So the concrete it doesn't dissolve into the acid solutions, whereas normal concrete if we put light of acid, so we start having that reaction with the acid and the cement which is contained into the concrete part, and does not generate any deleterious alkali aggregate reaction even in the presence of a high alkalinity. Means if we add the acid we are able to have the alkali aggregate reaction, whereas the aggregates are having the alkalinity presence in them which start having the highest alkalinity part and which will deteriorate the concrete. That type of reactions may not take place into the geopolymer concrete. It possesses excellent resistance to sulfate attack. Then next comes application of geopolymer, where all the geopolymer concrete can be used. As a marine structures it can be used because it is less in alkaline aggregate reaction. Precast concrete products, pre-stressed concretes or precast concrete products we can use. Railway sleepers we can use taking heavy loads. Sewer pipes we can use. Sewer pipes, the pipe culverts, then the culverts which are used to supply the pipe from water to one place to another place, that pipe conduits we can use. And other light load structures, and other light load structures means wherever the load is not so acting, means it is not used as the particular roads or heavy materials industries, that it is not used. The manufacturing of geopolymer concrete. The manufacturing of geopolymer concrete holds fresh concrete had a stiff consistency and with a glossy in appearance. Due to the polymers present into the concrete, there will be a glossy appearance. And stiff consistency means the harsh concrete will be there because the polymers will absorb some amount of water which is present in the concrete. The mixture was cast in 100 into 200 cylinder in 3 layers. So we are not mixing it on the ground, whereas the normal concrete and all other concretes are mixed on the ground sometimes. So that type of mixing we are not doing. We are mixing into a particular closed box. We are taking a cylinder wherein there we are going to mix. Each layer was stamped with 60 times and vibrated for 10 seconds on a vibrating table. 5 cylinders were prepared for each test as a variable. We are for testing and all things we can do that. So that part is the manufacturing of geopolymer. Next comes the high strength concrete. The concrete is mentioned as high strength concrete when the concrete is having its compressive strength above 40 megapascal, means 40 Newton per square. In further development stage, the concrete uh, compressive strength rise to 50 to 60 megapascal, 50 to 60 Newton per square. The evidence of pre-stressed concrete technology techniques has given impetus for the making of high strength concrete. Means wherever nowadays the constructions are going, they all are of a pre-stressed concrete technologies. Means concrete is manufactured at the site itself only. Concrete sections are manufactured at the sites only. We are just placing from the sites to the particular positions. Means the plants which are there, they are preparing the required type of sections, the precast concrete structures. So these concrete structures are having the highest strength taking capacity. For that reason we call that the high strength concrete is used moreover in the pre-stressed concrete structures. Production of high strength concrete. There are the special methods of making high strength concrete, that is seeding, revibration, high speed slurry mixing, use of admixtures, inhibition of cracks, sulfur impregnation, use of cementitious aggregates. Seeding. This involves adding a small percentage of finely ground, fully hydrated Portland cement to the fresh concrete mix. The mechanism by which this is supposed to aid strength development is difficult to explain. This method may not be hold much promising. Means we are doing small amount of finely grounded, fully hydrated cement mix we are adding into the particular mix which will try, but the part is what how the strength is going to develop, it is more difficult. Means we are not able to have that mixing, the normal concrete mixing how we do usually. The concrete is mixed dry mix, then we add the water and the all homogeneity is found, but here the water is added earlier then we are spreading it. That is called as a seeding, wherein sometimes it takes a high strength, sometimes it doesn't take a high strength. So for that reason we can't promise it whether it holds good much or not. Revibration. Concrete undergoes a plastic shrinkage. Plastic shrinkage means when a fresh concrete is there, there are small cracks. So volume change will be there. That volume change is known as the plastic shrinkage. Mixing water creates continuous capillary channels, bleeding, and water accumulates at some place selected. All these reduce the strength of concrete. Controlled revibration removes all these defects and increases the strength of concrete. So usually normal concrete, if we place somewhere and in the formwork, we can see there was some of the water is standing on some surface, the water is flowing from some surface, and somewhere the particular air bubbles are coming, such as the capillary channels and all things. So these all are going to include the reduction of the strength. So if we continuously controlled revibration is done, it removes all types of these defects and increases the strength, wherein this also accumulates into the high strength concrete. High speed slurry. This process involves the advanced preparation of cement water mixture, which is then blended with aggregate to produce concrete. Higher compressive strength obtained is attributed to more efficient hydration of cement particles and water achieved in the vigorous bleeding of cement paste. So high speed slurry mixing means in this process we usually have what the cement water mixture is there. Means the cement water mixture is prepared separately and aggregate and fine aggregates are mixed separately. So to have the higher compressive strength we more efficiently mix them, particularly blending in the cement paste. So when the cement paste is prepared, that cement paste we use to pump it out. That pumping we can have the high speed slurry mixing. Use of admixtures. Use of water reducing agents are also known as produced increased compressive strength, which we have already seen in the admixtures. Inhabitants of cracks, that concrete fails by the formation of a propagation of cracks. If a propagation of cracks is inhibited, the strength will be higher. Replacement of 2 to 3% of fine aggregate by polythene or polystyrene lenticels 0.025 mm thick and 3 to 4 mm in diameter results in higher strength. So use of a polythene or a polystyrene into the fine aggregate, that is replacement with fine aggregate about 2 to 3%, can reduce the cracks which are developed in the concrete and which also results into the developing high strength concrete. They appear to act as a crack arrestor without necessitating extra water for workability. They act as a crack arrestor wherein extra workability water is not required. Concrete cubes made in this way have yielded up to the strength of 105 Newton per mm square. Sulfur integration. Satisfactory high strength concrete have been produced by impregnating low strength porous concrete by sulfur. The process consists of moist curing the fresh concrete specimens of 24 hours, drying them at 120 degrees centigrade for 24 hours, immersing the specimen in molten sulfur under vacuum for 2 hours, and then releasing the vacuum and soaking them for an additional half hour for further infiltration of sulfur. The sulfur infiltrated concrete has given strength up to 58 megapascal. So sulfur integration means high strength develop can be produced by low strength porous concrete by sulfur. So we are going to provide a small amount of sulfur into that. Most curing of a fresh concrete is specimen 24 hours, drying them at totally 120 degrees centigrades for 24 hours, and then again that particular concrete is immersed into the molten sulfurs under vacuum pressure for 2 hours. So that will be soaking all things, then additional half an hour for further infiltration of sulfur into the concrete pores. So this infiltrated sulfur will give the strength for the concrete sections of about up to 58 megapascal, that is 58 Newton per mm square, wherein again it raises the strength of the whole concrete specimen. Use of cementitious aggregates. It has been found that use of cementitious aggregates has yielded high strength. Cement found is a kind of a clinker. So cement found is a kind of a clinker which we have already seen. This glassy clinker when finely grounded results in a kind of a cement when coarsely crushed. So if we grind it finely, that time it results into a kind of a cement. When the coarsely it is kept, means as a coarse aggregate, if it is kept, it makes a kind of a aggregate known as alga. Using alga as a aggregate, strength up to 125 Newton per mm square has been obtained with water to cement ratio of about taking 0.32. Last, the high performance concrete. The concrete which possesses high workability means performance should be better. Strength is there, but also performance is weak. So we are only going for strength, not for the performance. Now performance has to be better. Performance has to be better means the concrete which possesses highest workability, highest strength, high modulus of elasticity, high density, high dimensional stability, lowest permeability and resistance to chemical attack is known as high performance concrete. A substantial of a quantity of mixing water is a fundamental step for making high performance concrete. Means when we add water, the water itself is going to make a proper fundamental step when we are going to prepare for the high performance concrete. So reduction of water cement ratio will result in high strength concrete, but not the high performance concrete. But reduction in water cement ratio to less than 0.3 will greatly improve the qualities of transition zone to give inherent qualities expected in the high performance concrete. So if we reduce that less than 0.3 and if we perform it for the highest workability or highest density or dimension stability, low permeability by vibration, revibration and all things, so we are able to have some part of high performance concrete also. adopting water cement ratio in the range of 0.25 to 0.3 and getting a high slump is possible only with the use of superplasticizer. Therefore, use of appropriate superplasticizer is a key material to making high performance concrete. The associated problem is the selection of superplasticizer and that of a cement so that they are compatible and retain the slump and rheological properties for a sufficiently long time till concrete is placed and compacted. So whenever we are going to prepare a higher strength or high performance concrete, we require water cement ratio to be within the 0.25 to 0.3 ratio range. Then the particular superplasticizer which we are using, that superplasticizer selection is most important because it has to be compatible and retain the slump. So whatever the slump we require, that slump is also depending upon the water cement ratio as well as what the superplasticizer which we are using. With that we have to again have the homogeneity, that what is the particular rheological properties of the concrete is being sustained for a long time sufficiently such that it takes load, it takes, it is a dense, it is a very high modulus of elasticity, it is very workable, lowest permeability, that all until the sufficient long time period that after it is placed and compacted. Thank you for today's video, and the special concrete video will be continued in the next video. Thank you so much.